Over the next 10 minutes, I would like to take you through a proprietary process developed by National Cheng Kung University in Taiwan. This process can actually address the various challenges around the world today. I am using addressing the national security issue with natural gas in my subtitle as a particular example. To begin with, here is the agenda of the presentation. Let's start quickly from the key events of the UN Global Climate Conference over the last 20+ years and the major developments and technology by the world scientists. And then zero in the power-to-gas projects, with focus on NCKU process in terms of its uniqueness, how it can help to resolve the challenges to the world, and its environmental significance. Let me go quickly through the chronological development of the UN Global Climate Change Conference over the last 20 more years. Please note that I skip a few years just to highlight the key events. Last year the 26 Colombian pesos was a focal event in Scotland that the whole world was watching it closely because of time urgency. Unfortunately, the results were much disappointing. Thanks God that the world leaders haven't given hope on our scientists.
But the bottom line is, exponentially, we get this going and cooking. I can't tell you exactly what the, X factor is, but this is going to go X times faster than it would otherwise. And that's what we need. If we don't get enough reduction somewhere in the 45% range over the next 10 years, we are blowing by 1.5 degrees. And that's a hard target. It's not easy to achieve. Everybody knows that. So we need everything we can conceivably do.
There are indeed many great developments by the scientists around the world. And the power-to-gas, PTG, project is a very promising one. Just for you to get a quick understanding about the process, let me use this Audi animation film. The Audi e-gas facility bond the CO2 into the fuel, making Audi e-gas a climate-neutral fuel. It runs on renewable electricity from sources such as wind and solar power. The first process step uses electrolysis to convert renewable electricity into hydrogen. When the hydrogen is combined with CO2 in the methanization facility downstream of the electrolysis, the result is synthetic, renewable natural gas, Audi e-gas. This can then be fed directly into the natural gas network and stored there. Audi e-gas is an energy-rich fuel that is chemically identical to fossil methane, the primary constituent of natural gas, and is ideally suited to powering internal combustion engines. There are, however, pros and cons for PTG. On one side, the output methane can be used directly in the car, or methane is mixed into the gas grid with hydrogen as a power source. On the other hand, the process needs very high temperature to work, and the carbon dioxide produced offset its initiative. Secondly, the process has a byproduct carbon monoxide which is a poison to the catalysts and shorten its operation long life. It is expensive to build up the plant and scale it up. With such, PTG can only be positioned as a buffer source for electricity. Now, coming to our process by NCKU. First and the foremost, we use it and see it as a resource, not a bad thing at all. It is considered a PTG project, but an upgraded version that can expand current PTG use to many applications. That makes the NCKU process both practical and political correctness. It is unique in its carbon dioxide capture unit that we have a special absorbent to catch over 90% of carbon dioxide and cut 30% of the cost as compared to other technology. As to our core technology other than methane, our process also have the high-valued ethane and propane. And its significance is the much lower operating temperature and pressure, the nearly 100% conversion, and the high contents of high-value byproducts. To summarize, it is versatile, effective, low cost, high throughput, and practically correct. With such, the process can help to resolve the many challenges around the world. Pollution from the petrochemical industry. The urgent need for us to reach carbon neutrality. Speed up the development of hydrogen energy. Last but not the least, the ongoing challenge in EU for the shortage of natural gas and the price increase. The advantages of NCKU process can help in many ways, to name the critical ones. The enhancement of hydrogen energy development. The integration of the green feedstock with other process to make the new revenue for petrochemical industry. Most of all, the availability of natural gas. To summarize this presentation, there is additional advantage of the process. Here is an estimate on the cost and the land required to build up a demo plant and scale it up. The message here is that you can be a good corporate citizen with privileged bragging right.